Hello there guys, welcome back to our YouTube channel CAD Camstar. Today we will design this thrust bearing assembly. You can see this is the exploded animation of our thrust bearing assembly. In this tutorial we are going to design this assembly in Solidworks 2018 with the help of the 2D drawing which we have. So before getting started, if you haven't subscribed our YouTube channel, subscribe our YouTube channel and hit the bell icon notifications to all so that you get notifications of all our latest uploads. Now I am going to use this 2D drawing in order to create our assembly. You can see this is the exploded view of our thrust bearing assembly, and it consists of the three parts: the upper and the lower race, which is these two parts, and the ball or roller, which is this, you can see, and the retainer is this plate consisting of several cutouts of holes. Now first we will design our first part, which is upper and the lower race, and this is our drawing, and all these dimensions which are mentioned here are in inches, so make sure you are working under inch system. This is the section view of our first part. So let's get started. First, I will enter into the part mode. Select file, select here new. Now select here part, click here OK. Now let me change background to plain white. Now select here inch, pound, second system. Now select here front plane, click here sketch. Now what I am going to do is create this half profile, which you can see here. This profile, I am going to create this half profile at a distance of this much distance from center line. Then I will use revolve command to create this whole profile. So first select here center line and create one vertical center line like this. Now go to smart dimension. Now you can see the total distance is 69.69 inches from this base here. So select a smart dimension, select this line. This will be 0.69 inches. Now again select a line command, create one line and add some constraint. Select this endpoint, hold down the control key. Select this endpoint, make them horizontal, same as here. Select this endpoint, hold down the control key. Select this endpoint and make them horizontal. Now we have to specify this gap. You can see the gap will be this one, 3.75 inches. It is the dia, so the gap will be half. Go to smart dimension, select this line, enter the value of 3.75 divided by 2 like this. Now select here line command. Now we have to sketch this profile, you can see. Now select line and create these profiles up to here and connect these two. Now you can see this is the fillet of dimensions. You can see here the dimensions of 0.12 and angle will be 45 degree. Sorry, this is a chamfer. So select this one. This will be 0.12 like this, and angle will be 45 degree. So select this and this edge. This will be 45 degree. Now You can see there is one more chamfer on the lower edge of 0.06 inches. Now select here chamfer, select this edge, first select here distance 0.06, select here angle distance, angle will be 45 degree. Now select this one. Now you can see now we have to specify some distance. You can see this distance is 5.27 from this edge to this edge. Let me zoom in. From center line it will be half. So select the center line, select this edge. This is 5.27, so this will be 5.27 divided by 2, like this. Now you can see this distance is 5.88, so select the center line, select this one. This will be 5.88 divided by 2, like this. Now we have to create this inner profile. For that, select here line command. Again select line command and create this profile. Now select here trim entities, trim this portion. Now select a smart dimension. Now you can see this gap is 0.25 inches. Select this one. This will be 0.25 inches. Now from here up to here it is 0.75 inches. So select this edge and select this base edge. This is 0.57. Now one more relation we have to specify. You can see from this top view, this dia is 4.79. It is from here up to here, the outermost point where the rollers will attach. This is 4.79, so this will be 4.79 divided by 2, like this. Now go to features, select here revolve boss base. Now you can see it has automatically selected the profile. Now click here OK. This is our first part, upper and the lower race. Now we will add some appearance to it. Select here metal, select steel and select here brush steel. Now save this part. This is part number 1, upper or lower race. And in the next step we will create our next part, which is this retainer. Now we will design our next part, which is part number 2, retainer. This is the drawing of our part. These dimensions are in inches. So let's get started. First select your file, select your new, select your part, click here OK. Now let me change background to plain white and select here inch pound second system. Now select here front plane, click here normal to and select here sketch. Now first I will create these two circles of dia 3.55 inches and 4.80 inches. Select here circle command, snap this origin point, create here two circles, go to smart dimension, select this inner one, dia will be 3.55 as mentioned here. Now the outer one will be 4.80. Select this outer one, enter the dia of 4.80. Now we will create one construction circle of radius 2.09 inches. Select circle, select here construction, smart dimension, its radius will be 2.09. So the dia will be 2.09 into 2 multiplied by 2, 4.81 inches, 4.18 inches. Now select here center line, snap this origin point, create one center line up to here. Now select here circle command. Now we will create this circle of dia 0.50 inches. Snap this point, create one circle. Its dia will be 0.50 inches. Now select here pattern and circular pattern. Now it will ask for the select here quantities is 24. Enter the 24 quantities. Select here equal spacing, select 360 degree and select here entities to pattern this circle. Now it has automatically snapped the direction. If not, select this point or center. Now click here OK. Now you can see our pattern is ready. Now go to features. Now you can see the thickness is 0.10 inches. Go to features, select here extrude boss base, select here mid plane, enter the value of 0.10 inches, click here OK. You can see our part number 2 retainer is ready. Now I will add some appearance to it. Select here brushed steel, now save this part. This is part number 2 retainer. In the next step we will create our next part, which is last part, ball or roller. Now we will design our next part, which is the last part, part number 3, ball or roller. You can see this is our part and this is the drawing of our part number 3 and these dimensions are in inches. So let's get started. Go to file, select here new, select here part, click here OK. Now select here background plain white and select here inch pound second system. Select here front plane, click here sketch. Now select here line command, create one line, move cursor back and forth towards the end point and convert it into the arc. Now you can see the dia is 0.5 inches. So select this arc, its radius will be 0.25 because the dia is 0.5 inches. Now go to features, select here revolve boss base. Now select this axis of revolution and the profile will be this remaining. It has automatically selected. If not, go to selected contours, select this region, click here OK. Now this is our part number 3, ball or roller. Now I will add some appearance to it. Select here brass. Select here sand blasted brass. Now save this part. This is part number 3, ball or roller. Now click here save. Now we have created all our 3 parts which are required to create this thrust bearing assembly, and in the next step we will assemble all our components one by one and create this assembly. Now we will create the assembly of our thrust bearing with the help of the parts which we have created earlier. Now go to file, select here new, select here assembly, click here OK. Now first I will select here background to plain white so that you can easily view. Now select here inch pound second system. Now go to assembly, select here insert component, select part number 1 and part number 2, ball and roller and retainer. Now import these parts. Now you can see the first part which we have imported is fixed by default and the other parts are float. Now what I'm going to do is fix this part and float this one. Now select on this eye icon and view temporary axis and view axis. Now you can see our axes are viewable. Now go to mate, select this axis and any of the axis of the holes. Suppose I select this one, make them coincident, click here OK. Now you can see both their axes are mated. Now let me uncheck these. Now what I'm going to do is expand this ball and roller and expand this retainer. Now select here mate. Now select the top plane of this ball and roller and select the front plane of this retainer which is exactly at the middle, and select here distance mate. Distance will be 0.25 inches because we want exactly at the middle this ball or roller. Now cancel this mate command. Now we have to pattern this in all these holes. For that select here circular pattern. Now quantities will be 24, angle will be 360 degrees. Select here equal spacing components, select this roller and direction, select this inside surface. You can see it is showing the preview. Now click here OK. Now our middle portion is ready. Now we have to import the upper and the lower race. Now import this part. Now select this retainer, make it float. Now select this upper and lower race, make it fix so that I can easily move them. Now select a mate command. Now select this inside surface. By default it has selected some clear section. Select this inside surface and select this inside surface and make them concentric. Click here OK. Now select this sphere and select this surface, make them tangent, click here OK. Now you can see it can move in this slot. Now we have to import it again to create the other half. Now select here mate command. Select this inside surface. Select this inside surface. Make them concentric. Click here OK. Sorry, the mate will be opposite. Expand this mate section. Select this mate and edit here concept. Now click here mate alignment like this. Now select your mate, select this face and this face. Make them coincident, click here OK. Now our assembly is ready. You can save this assembly. This is our thrust bearing assembly. If you like this video, please like, share and subscribe our channel and hit the bell icon so that you get notifications of all our latest uploads. Thank you.